All right, we've got our last video here. We're going to apply the angle bisector theorem. So why don't I tell you what the angle bisector theorem is? So the theorem says if a point is on the bisector of an angle, so here we're talking point D, ray AD, I know is the bisector of angle BAC because I have two congruent angles right here. So I know that ray AD is in the middle of it, bisecting it. So if a point is on the bisector of an angle, then it is, and I think I've been saying this word wrong, equidistant. I keep saying equidistant, but it's equidistant from the two sides of the angle. All right, so if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So that means that in our picture, BD would be equal to CD. All right, we have the converse of that as well. This time, you're starting out with a point that is equidistant from the two sides of an angle. So if a point is equidistant from the two sides of an angle, here point D we can see is the same distance away. And by the way, it's the distance away and forming a right angle. So perpendicular distance away from the angle. Then it is on the angle bisector. So if a point is equidistant from two sides of an angle, then it is on the angle bisector. So if it's on the angle bisector, that means that this angle is congruent to this angle. So we can say the measure of angle BAD is equal to the measure of angle CAD. All right, let's apply our theorem, put it to use, apply it. Up here it says apply the angle bisector theorem. What is the value of KL? So I'm going to zoom in a little bit here so we can see this a little bit bigger. So what do we notice about the picture? We want to figure out the value of KL right here. Well, KL is 2x plus 3. So if we know the value of x, we can find the measure of KL. So let's figure out how do we get that measure of x. We notice that we have over here angle J. Angle J has this ray JL coming out of it, which is producing two congruent angles right here. So angle KJM is being bisected by ray JL. So because we have two congruent angles, that makes JL an angle bisector. Any point on your angle bisector will be equidistant from the sides of your angle. So that tells us that KL is the same distance as ML. So that is the equation we can write. 2x plus 3 is equal to 4x minus 11. And then let's go ahead and solve this equation. We have x's on both sides of our equal sign. Let's get those to the same side first. It doesn't matter if you move the 2x to the 4x. I'm just going to go ahead and subtract the 4x from both sides. This will give us a couple good things to talk about. 2x minus 4x is negative 2x plus 3 equals, we want to be aware that is a negative 11 that we're going to carry down. All right, let's go back to where the x is. We've just got two steps to solve. We will subtract 3 from both sides. Negative 2x is equal to, that's going to give us a negative 14. Last step, divide both sides by 2. So x is equal to, the negative divided by a negative will give us a positive 7. So have we answered the question? Have we found the value of KL when we figured out that x was 7? And we have not, so we have a little bit of follow-up to do. In our picture, we can see that KL is equal to 2x plus 3. Now that we know that x is a 7, let's plug in a 7 for that x. That gives us 14 plus 3, which means that KL is equal to 17.